Planet Earth is a world of constant motion. The oceans are no exception. They ebb and flow in a rhythmic cycle known as tides. Tides are the periodic rise and fall of sea levels. These changes are driven by a powerful, invisible force, gravity. Tides are crucial to the balance of our planet. They influence marine ecosystems, shaping the habitats of countless species. For coastal communities, understanding tides is essential for navigation, fishing, and recreation. The study of tides is a fascinating journey into the intricate workings of our planet and the celestial bodies that influence it. The Moon, Earth's closest celestial companion, plays a dominant role in shaping the tides. Although much smaller than the Sun, its proximity to Earth gives it a stronger gravitational influence over our oceans. Gravity acts like an invisible tether pulling objects towards each other. The Moon's gravity tugs at the Earth and, most importantly, at the water on Earth's surface. This gravitational pull is the primary cause of the tides. As the Moon circles our planet, its gravitational force creates a bulge of water on the side of Earth facing the Moon. This bulge is not a static wall of water but rather a dynamic wave that follows the Moon's orbit. The Moon's gravity doesn't just create a bulge on the side facing it, it also has a profound effect on the Earth's oceans, creating the rhythmic rise and fall of sea levels that we know as tides. This gravitational pull is a powerful force that shapes our coastal landscapes and influences marine life. When the Moon's gravity pulls on the Earth's oceans, it creates a bulge on the side of the Earth that is closest to the Moon. This is what we call a high tide. But the story doesn't end there. On the opposite side of the Earth, another high tide occurs. This might seem counterintuitive at first, but it's a fascinating result of the interplay between gravity and inertia. This second bulge, or high tide, on the far side of the Earth happens because of inertia. Inertia is the tendency of an object to resist changes in its state of motion. Essentially, the water on the far side of the Earth is trying to keep moving in a straight line away from the Moon, creating a second bulge. Inertia plays a crucial role in this process. Imagine a bucket of water being swung around in a circle. The water inside the bucket pushes outward, trying to escape the circular motion. Similarly, the water on the far side of the Earth is pushed outward, away from the Moon, due to inertia, forming the second high tide. The water on the side of Earth farthest from the Moon experiences less gravitational pull and tries to continue moving in a straight line, creating a bulge. This is a delicate balance between the gravitational forces of the Moon and the inertia of the water. As the Earth rotates beneath these two tidal bulges, coastal areas experience high tides when they pass under a bulge, and low tides when they are between bulges. This constant movement of water shapes our coastlines, erodes rocks, and creates unique tidal ecosystems. This cycle repeats approximately every 12 hours and 25 minutes, resulting in 2 high tides and 2 low tides each day. The regularity of this cycle has been a reliable natural clock for coastal communities for centuries, influencing fishing, navigation, and even cultural practices. Coastal communities have long relied on the predictability of tides. Fishermen plan their trips based on the tides, knowing when the waters will be high enough to bring in their boats or low enough to expose rich fishing grounds. The rhythm of the tides is woven into the fabric of daily life for those living by the sea. Marine life is also deeply affected by the tides. Many species have adapted to the changing water levels, with some thriving in the intertidal zones that are alternately submerged and exposed. Crabs, starfish, and various types of seaweed are just a few examples of organisms that have evolved to live in these dynamic environments. For beachgoers, the tides can mean the difference between a wide, sandy beach and a narrow strip of land. Collecting shells, building sandcastles, and exploring tidal pools are all activities that depend on the timing of the tides. The ebb and flow of the ocean create a constantly changing playground for those who visit the shore. The tides are a reminder of the Moon's silent influence over our planet. They connect us to the rhythms of the natural world, reminding us of the delicate balance that governs our environment. Whether we are aware of it or not, the tides shape our world in countless ways, from the grand scale of ocean currents to the simple joy of a day at the beach. Section 4. The Sun's subtle influence. While the Moon is the primary driver of Earth's tides, the Sun also plays a role. The gravitational pull of the Moon is the dominant force, but the Sun's influence, though less pronounced, is still significant and cannot be ignored. Although much farther away from Earth than the Moon, the the sun's massive size means its gravitational pull is still significant. The sun is about 93 million miles away from Earth, compared to the moon's average distance of about 238,855 miles. Despite this vast difference, the sun's gravitational force is powerful due to its immense mass, which is about 333,000 times that of Earth. The sun's gravitational influence on tides is about half as strong as the moon's. This means that while the moon is the primary force behind the rise and fall of the tides, the sun's gravitational pull adds an additional layer of complexity to the tidal patterns we observe. Its influence becomes most noticeable during specific alignments of the Earth, Moon, and Sun. These alignments, known as syzygies, occur when the three celestial bodies form a straight line. During these times, the combined gravitational forces of the Moon and the Sun work together to create more extreme tidal conditions. These alignments, which occur during new and full moons, create the most extreme tidal ranges known as spring tides. During a new moon, the Sun and Moon are on the same side of the Earth, and their gravitational forces combine to pull the ocean's water in the same direction. During a full moon, the Sun and Moon are on opposite sides of the Earth, but their combined gravitational pull still results in higher than normal tides. Conversely, when the Sun and Moon are at right angles to each other, their gravitational forces partially cancel out, resulting in neap tides with more moderate tidal ranges. Neap tides occur during the first and third quarters of the lunar cycle, when the gravitational pull of the Sun partially counteracts the pull of the Moon, leading to less extreme tidal conditions. These more moderate tides are a fascinating example of how the interplay between the Sun and Moon's gravitational forces shapes the natural rhythms of our planet's oceans. Section 5. Spring tides. When forces align. Spring tides occur when the Sun, Earth, and Moon are aligned in a straight line. This alignment is a fascinating celestial event that has profound effects on our planet's oceans. This alignment occurs during both new moons and full moons. During these phases, the gravitational forces of the Sun and the Moon work together, amplifying their effects on Earth's tides. During a new moon, the Sun and Moon are on the same side of Earth. This means that their gravitational pulls are combined, creating a stronger force that affects the ocean's tides. During a full moon, they are on opposite sides. Despite being on opposite sides, the gravitational forces of the Sun and Moon still work together to create significant tidal effects. In both cases, the gravitational forces of the Sun and Moon combine. This combination results in what we call spring tides, which are characterized by higher high tides and lower low tides. This combined force creates a stronger pull on Earth's oceans, resulting in higher high tides and lower low tides than usual. The difference between high and low tides is more pronounced during spring tides. Spring tides are not named for the season but rather for the way the tides spring forth with greater intensity. The term spring in this context refers to the sudden and dramatic increase in tidal range. These tides are a dramatic illustration of the powerful interplay of gravitational forces in our solar system. The Sun and Moon, despite their vast distances from Earth, exert a significant influence on our planet's oceans. The gravitational pull of the Moon is the primary force behind the tides, but the Sun's gravity also plays a crucial role. When these forces align, their combined effect is what creates the spring tides. Understanding spring tides helps us appreciate the delicate balance of forces that govern our natural world. It also highlights the interconnectedness of celestial bodies and their impact on Earth. The phenomenon of spring tides is a reminder of the dynamic and ever-changing nature of our planet. It shows how even distant celestial events can have a direct and tangible impact on our daily lives. Next time you witness the dramatic rise and fall of the tides, remember the cosmic dance of the Sun, Moon, and Earth that makes it all possible. The forces at play are a testament to the beauty and complexity of our universe. Section 6. Neap tides, a balancing act. In contrast to spring tides, neap tides occur when the Sun and Moon are at right angles to each other relative to Earth. This alignment occurs during the first and last quarter moons. During neap tides, the Sun's gravitational pull partially counteracts the Moon's pull. This balancing act results in less extreme tidal ranges. High tides are lower than usual, and low tides are higher.